Chapter 5, Example 4. The SAT reasoning test has 3 parts: writing, math, and critical reading. Each part has a distribution that is unimodal and roughly symmetric, and is designed to have an overall mean of about 500 and a standard deviation of 100 for all test takers. In any one year, the mean and standard deviation may differ from these target values by a small amount, but they are a good overall approximation. Suppose you earned a 600 on one part of your SAT. Where do you stand among all students who took the test? As we did in the previous example, the first thing we have to do is verify that it's appropriate to use the normal model, which means, is the distribution unimodal and roughly symmetric? In this case, the problem specifically tells us that. So we're set. We just have to make sure that we write this down. We have to communicate that. So, since each test has a distribution that is unimodal and roughly symmetric, it is appropriate to use the normal model to discuss SAT scores. Remember, normal is the name of a test, so we have to capitalize that. Okay, so now we want to find that z-score. We know you have a score of 600. We know all the other information, so z equals 600. The mean was 500 with a standard deviation of 100, which conveniently comes out to be a standard deviation of 1. Okay, so a score of 100 would be 1 standard deviation above the mean. So, what does this really mean for us? Let's start by sketching a picture. We love doing that always. Picture, picture, picture. So, sketch our normal curve. Not completely symmetric, but we get the idea. So right here is a score of 500. Our standard deviation is 100, so the inflection point right about there, our first standard deviation is always the inflection point where the concavity of the curve changes. And so that's going to be 600 on the left, 600 on the right, 400 on the left. then we want about the same distance among those. So right about there is 700, way down there is 800, which would be 700 is 2 standard deviations away, 800 is 3, and then 300 would be 2 standard deviations away on the negative side, and 200 would be a really low score on the right hand side. Now, using the empirical rule, we know roughly 68% of all scores are 1 standard deviation away. 95% are right there, 2 standard deviations away. And 99.7% of all scores are in between 3 standard deviations. We're fortunate this comes out to be exactly 1 standard deviation, so we are right here at 600. Now, if 68% is inside that area, that means there's 32% outside. So we have 16% here and 16% of scores above, which means your score of 600 is in that top 16%. So let's write that out. A score of 600 would place me in the 84th percentile. 16, because you go up to 100, 100 minus 16 is 84. About 84% of those that took the test would be, let's go with B instead of would have been, be expected to have a score that is lower than mine.